You are made of information that cannot die. Here is something physics actually says. Not metaphor, not poetry, actual physics. The information that defines every particle in your body cannot be erased. It can be scrambled. It can be scattered across 1 billion light years. But destroyed? The universe appears to have a rule against that. And the strangest part? Nobody fully understands why. Stick with this, because by the end, the question isn't just about physics. It's about what you are, what you were before you were born, and what happens to you after everything you call you is gone. In 1974, a physicist named Jacob Bekenstein was staring at equations about black holes. He was 26 years old. He wasn't supposed to be working on this. His supervisor, the great John Wheeler, had basically handed him a problem as a warm-up exercise, something to keep him busy. The problem was simple on the surface. Black holes swallow things. What happens to the information about those things? Bekenstein did the math. Then he did it again. Then he wrote down something that made physicists furious for the next 50 years. He said black holes have entropy. Now, entropy is a word that sounds technical, but the idea is almost childishly simple. Entropy is just a measure of how many ways something can be arranged. A clean bedroom has low entropy. One arrangement, everything in its place. A destroyed bedroom has high entropy. 1,000 different ways the clothes could be on the floor, the book scattered, the lamp knocked sideways. More arrangements, more entropy. Bekenstein said black holes carry entropy, which meant they carried information. Information about everything they had ever swallowed. Stephen Hawking hated this idea. He said Bekenstein was wrong. He set out to prove it, and then he accidentally made everything worse. In 1974, the same year Bekenstein published his paper, Hawking sat down and applied quantum mechanics to the edge of a black hole. Quantum mechanics is the rulebook for how the very smallest things in the universe behave. And at the very smallest scales, empty space isn't actually empty. Here's how to picture it. At the quantum level, space is fizzing. Pairs of particles are constantly popping into existence and then immediately annihilating each other. They borrow energy from the vacuum, do their brief, violent dance, and vanish before the universe notices the debt. This happens everywhere, all the time, even in your living room right now. At the edge of a black hole, something goes wrong with this process. One particle from a pair falls in, the other one escapes. The black hole has to pay the energy debt from its own mass, so it loses a tiny, tiny amount of mass. Over an incomprehensibly long time, it radiates away. It shrinks, and eventually, gone. Hawking called this Hawking radiation. He thought it was his masterstroke against Bekenstein. If black holes evaporate, he said, then all the information about everything they ever swallowed is gone too. Cooked into featureless thermal radiation. Random noise. The universe forgets. But here's the twist nobody expected. If Hawking was right, then physics breaks. Not breaks like a machine that stops working. Breaks like the fundamental rules of reality become self-contradicting. Quantum mechanics has a law at its core. Information is always conserved. You can scramble it, you can encrypt it beyond any hope of reading, but you cannot delete it. The past is permanently written into the present, even if you can't read the handwriting. Hawking was essentially saying the universe commits a crime every time a black hole dies. And the universe doesn't do that, does it? This became the information paradox, and it is still not fully solved. That is a fact. Physicists have been arguing about it since 1976. Some of the smartest humans alive today go to sleep thinking about it and wake up with the same open question. But somewhere in all that argument, something extraordinary started to emerge. An idea so strange that it reframes not just black holes, but everything. And the strangest thing in this entire video is still ahead. In the 1990s, a physicist named Gerard 't Hooft proposed something that sounds like science fiction. He said maybe the inside of a black hole isn't where the information lives. Maybe all the information about everything inside a black hole is encoded on its surface, the two-dimensional boundary. Like a hologram. You know how a hologram works. A flat piece of film. A laser hits it. A three-dimensional image floats in the air. All the information for 3 dimensions is stored in 2. 't Hooft was saying the same thing happens with black holes. The surface encodes the volume. The boundary contains everything that appears to be inside. Then a physicist named Juan Maldacena took that further. In 1997, he showed mathematically that certain descriptions of gravity in 3-dimensional space are exactly equivalent to quantum mechanics on the 2-dimensional boundary of that space. Same equations, different dimensions. One description of reality perfectly mirrors another. This is called the holographic principle. And here's where it stops being just about black holes. Some physicists now think it applies to everything. The entire observable universe might work this way. Everything you see, every galaxy, every star, every rock, every thought you've had today, all of it might be a kind of projection. Encoder on a boundary surface at the edge of what we can observe. 3-dimensional reality as information written on 2 dimensions. Now, I want to be careful here. This is a current working theory, not a settled fact. Physicists debate it vigorously, but the mathematical machinery behind it is real, and it works. The equations behave. And if they're right, then the universe isn't made of matter and energy in the way we usually think. It's made of information. Information that cannot be destroyed. Information that the universe stores, always, somewhere. Which brings us back to you. Every atom in your body has a history. Trace any carbon atom in your hand back far enough, and it was forged inside a star that died before the sun existed. That's a fact, not metaphor. A real star burned hydrogen into helium, helium into carbon, and then exploded. The carbon drifted. Over millions of years, it ended up in a cloud, then a planet, then a living thing, then you. But it's deeper than that. Because atoms aren't really things, they're patterns. An electron isn't a tiny ball sitting in an orbit. It's a probability wave, a description of where and how something is likely to be. It's defined by its quantum state, which is a complete record of everything that has ever happened to it. You are a walking archive, a library built from the quantum states of roughly 7 billion atoms, each one carrying information going back to the beginning of the universe. When you die, those atoms scatter. The pattern that was you disperses. But the information doesn't disappear. Physics says it cannot. It gets scrambled, redistributed. The pages of the book get torn out and blown across a city, but they're still there. Now here's the question that wakes people up at night. Is that enough? Is the scattered information still you? Or is you only the pattern, only the arrangement, and once the arrangement breaks, that's it? Most physicists would say the information is preserved, but the pattern is gone. The book exists, but it can never be reassembled. The you of right now is a one-time configuration that will never recur. But some physicists push further, and here's where it gets genuinely strange. In a universe that is infinite, or even just unimaginably large, probability does something uncomfortable. Given enough space and enough time, every possible configuration of matter eventually recurs. Every arrangement of atoms that could exist will exist. Somewhere. Not nearby, not soon, but the mathematics doesn't forbid it. This is called the Boltzmann brain argument, named after physicist Ludwig Boltzmann, who terrified himself with it in the late 1800s. He spent years thinking about entropy, about the way ordered things become disordered, and he arrived at a horrifying corner case. In a vast enough universe, random thermal fluctuations could spontaneously assemble anything, including a brain. A brain with false memories of a life that never happened, floating in the void. Boltzmann eventually took his own life. Whether the idea drove him there, nobody knows. But the physics he found was real enough that modern cosmologists still argue about it. Here's what it means for you. If the universe is vast enough and old enough, then somewhere in the infinite spread of space and time, the exact quantum configuration that is you right now might spontaneously recur. Not you approximately, not you more or less, you. This exact pattern, this exact moment, reading these exact words, with this exact sense of wondering whether any of this is true. Is that you? Is that the same person? Or just a copy so perfect that the copy doesn't know it's a copy? This isn't settled. It might not be settable. But the question itself is not crazy. The mathematics behind it is real. Physicists don't dismiss it. They lose sleep over it. And then one more thing. One more layer underneath all of this. Here's the part I keep coming back to. The part that feels like pressing on a bruise. Information might be eternal. The universe might have a hard rule against deleting it, but what was being written before the Big Bang? The honest answer is that we don't know. And here's where it stops being a knowledge problem and starts being something stranger. Time itself, as we understand it, might not have existed before the Big Bang. Stephen Hawking and physicist James Hartle proposed something called the no-boundary proposal. The idea that asking, what came before the Big Bang, is like asking, what's south of the South Pole? The question doesn't fail because we don't know the answer. It fails because time, as a dimension, had no edge to be before. That should feel strange. Let it. If time began, then the information that makes up reality didn't exist in any previous moment. There was no previous moment. The universe didn't begin from something. It began from a configuration of quantum information that had no prior state, which means you have no origin before the origin. The information that defines every particle in your body traces back to a starting point that had nothing behind it. Not darkness, not void, not waiting. Those are still places, still times. The no-boundary proposal says there was genuinely nothing, no before. The universe remembers everything that has happened since that first quantum fluctuation, but it cannot remember before. Not because the memory was lost, because there was never anything to remember. Now look at what you are sitting inside of. A universe that refuses to forget anything since the first moment, that stores every quantum state of every particle in some form always, that may encode all of reality onto a boundary surface the way a hologram stores depth on a flat film, that might, in its vastness, recur every configuration that physics allows. You are a temporary arrangement of permanent information. The pattern breaks, the atoms scatter, but the record stays. Somewhere in the structure of reality, encoded in a way we can't yet read, the information that built this version of you is written down, not preserved in some comforting afterlife sense. Not you, conscious, continuing. The laws of physics don't promise that. But something more unsettling and more real. The data of you persists. The quantum signature of every particle that ever composed you, every interaction, every collision, every moment of being alive. It doesn't vanish. It folds into the ongoing information state of the universe. Physics says the universe can scramble that, scatter it, hide it across distances so vast that no power could ever reassemble it. But erase it? No. The rule appears to hold. Information cannot be destroyed. Which means, in some precise, literal, physics-based sense, everything you have ever been is still out there. Not accessible, not recoverable, but not gone. Carl Sagan said we are a way for the cosmos to know itself. Billions of years of nuclear fire, gravity slowly sculpting gas clouds into stars, stars exploding and scattering the raw materials of chemistry into the dark. Chemistry folding into biology. Biology wiring itself into nervous systems capable of looking up, looking out, and asking what's there. That process produced something the universe had never had before, an internal observer, a part of the universe that can turn around and look at the rest of it. You are not separate from the cosmos examining it through a telescope. You are the cosmos, a local, temporary arrangement of its information turned inward, generating the experience of being a person. And when that arrangement ends, the information rejoins the rest. So here's the question, the one I can't stop sitting with. If the universe never forgets anything that has existed within it, what does it mean that you existed at all? More Cosmos tomorrow. Be here. If this was worth your time, subscribe. And tell me what I got wrong. I read every comment.